Good morning, everyone. Today I'm going to talk about a fascinating topic in distributed computing, that is client-server process communication using the remote method invocation, or simply RMI. Let's start with a simple idea. In many applications today, whether it's banking system, an e-commerce platform, or even a cloud service, we have multiple systems communicating with each other. The client is the one that requests a service, and the server is the one which provides it. Now imagine you have a Java program running on one computer and you want to call the method that exists on another computer, just like you call a normal function in your code. That's where RMI comes in. Our remote method invocation allows one Java object to invoke methods of another Java object on different Java virtual machines, possibly running on another computer connected via network. It hides all the complexity of the network communication, serialization, and data transfer, and let developers write the distributed programs as if everyone was local. Let's now look at the core components that makes the RMI work. There are five key components involved in every RMI system. Client. The client is the application that wants to use the remote objects. It calls the method, defines in an interface that's shared between both the slides. Server is where the remote object actually resides. It provides the implementation of the methods declared in the remote interface. Then remote interface, this is a special interface that defines the methods which can be called remotely. It acts as a contract between the client and the server. The interface extends the java.rmi.remote interface, and every method throws a remote exception. Stub and skeleton. The stub acts as a proxy on the client side. It forwards the client's method call to the server over the network. The skeleton resides on the server side and receives these calls, unpacks the data, and forwards the request to the actual implementation. RMI registry. This is like a phone directory where the server starts. It registers its remote object with a specific name in the RMI registry. The client then look up that name to obtain the reference to the remote object.
System workflow. Let's understand how the system actually works step by step. Server initialization. The server starts first. It creates an instance of the string manipulation service and registers it with the RMI registry using a unique name like string service. Client lookup. The client running on a different machine connects to the same registry and looks up string service. The registry then returns a stub, a local proxy representing the remote object. Method invocation. When the client calls a method, say to uppercase string hello, the stub takes that call, serializes the parameter, and sends the request across the network. Server processing. The server receives the call via the skeleton, decentralizes the data, executes to the uppercase method, and converts lowercase hello string into uppercase hello string. Response delivery. The server then sends the result back to the client stub, which finally delivers uppercase hello string to the client program. Multi-threading in action. If multiple clients sends requests at the same time, the RMI framework automatically creates separate thread for each request. This ensures all clients are served concurrently without delays. So even though the client and the server are on a different machine, RMI makes it look like both are working together seamlessly in a single Java environment.
About how this is actually implemented, not with raw code but by understanding the structure. The server side involves three main parts: remote interface, implementation class, and server program. In remote interface, the remote interface declares the methods. The interface ensures both the client and the server know what methods are available and what parameters they take. In implementation class, this is the real brain of the server. It implements the interface and provides the actual logic. It also automatically manages client threads in the background, enabling multi-threading. For server program, we can see the main server program creates an object of the implementation class and registers it with the RMI registry. Once this is done, the server starts waiting for client request. Whenever a new client calls a method, RMI automatically creates a new thread to handle that call. This design makes the system both distributed and parallel, ensuring reliability and scalability. Advantages and real-life applications. Advantages and real life 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 applications. Advantages and real Now, let's discuss some of the major advantages and real world applications of RMI. In advantages, we can see simplicity, object oriented, automatic multi-threading, platform independence, security, and exception handling. In simplicity, we can see RMI makes network communication like simple method calls. Developers don't have to manually handle sockets, streams, or protocols. In object oriented, it maintains Java's object oriented principles, letting you pass and receive complete objects over the network. For automatic multithreading, each remote call is handled in a separate thread automatically, allowing simultaneous client connections. For platform independence, since RMI is purely Java based, it's fully portable across any system that runs the JVM. The security and exception handling is built in security managers, and remote exception handling make it robust and secure. For real life applications, we can see banking systems, online multiplayer games, remote data processing systems, IoT and sensor networks, enterprise distributed applications. To wrap up, remote method invocation is one of Java's most powerful mechanisms for building distributed and networked applications. It allows different JVMs, even on different machines, to communicate and collaborate as if they were part of a single system. Through our string manipulation use case, we saw how the client-server model works with RMI, how methods are called remotely, and how multithreading ensures concurrent execution for multiple clients. RMI simplifies what would otherwise be a complex task of networking and communication. It provides a strong foundation for understanding how distributed systems function in the real world. So whether it's remote computation, data processing, or cloud-based services, RMI is a great stepping stone to learn distributed communication in Java. Thank you.